you a little bit about myself. I've been involved in technology and management and business side of things for many, many years. In the 1980s in particular, I came out of the academic world in the 70s. My primary background is a theoretical mathematician, cognitive psychologist, anthropologist, and linguist. I got an interest in artificial intelligence and wound up very quickly managing teams and research projects and startup companies, and I was the guy who had to do all the managing. And one of the problems that I ran into really early on was getting people to work together. And all of the classical problems we have with this black slack disorganization, I experienced them all. And so I was always looking for ways to be able to manage that underlying CMS configuration management system layer in a way that was effective, because I realized it was just totally undercutting what we were doing. And also we were always looking for ways to get people to talk to each other. As it turns out, as I went through the 90s and the early 2000s, I started doing a lot of consulting and training in organizations all over North America, from Wall Street to defense contractors to pharma. I noticed that hey, I wasn't the only one who had this problem. Everybody was struggling with these issues of how do we keep track of what we've got, and all of the kinds of issues of, but how do we get our people to share work? How do we get them to collaborate? And everybody was trying different kinds of solutions. And I keep telling people I was never the smartest guy in the room, but I always got a chance to see what the smartest people in the room were doing. And these kinds of seminars are an opportunity for me to try to convey what the smart people in the room do. So I'm trying to act as kind of like the anthropologist in the field, reporting back and saying, I've observed the natives in their native habitat on a project, and this is what they do. These are the rituals they engage in, but they're actually pretty good. A while ago, Linus Torvalds launched this little hobby project called Linux. And it, of course, took off a little bit more than he expected initially. And he started developing the Linux kernel team, and they were having problems with exactly the same issues that I have. But of course, Linus, being one of the smart guys in the room, came up with a solution. They invented GitHub, or they invented Git. And they came up with a collaborative model, which was really quite built. They've been using, I think they were using SVN, or they might have been using Mercurial. I can never remember quite what it was, but it wasn't. But whoever they were working with wasn't responding to them saying, "Hey, we need this, we need that," and so they just said, we'll do it ourselves. And so this has come out of that project, but it's taken off tremendously. GitHub is it is by a mile one of the leading repository, or is the leading repository for collaborative work. And it's not just people sharing code, it's also people doing entire projects, people writing books. I use GitHub and Git for a wide number of reasons. For example, I do a lot of writing. All of my writing's in Git and GitHub. Because I share it with my editors, and I edit other people's work. And GitHub is growing tremendously. It's got literally millions of repositories. Every single significant IT project in the open source community now has often related to a GitHub repository. I'm actually teaching a class today on secure coding, and all of the course materials and everything has been relayed to my students through GitHub. So this is becoming a kind of standard for how we do things. But it also is a little bit mysterious to people who have not experienced or been through kind of the trenches working with it. So my objective today is to demystify Git and GitHub, to give a very high-level overview of what they do and what they can do and how they work. Because I find a lot of people are a bit intimidated by sort of, well, it's GitHub, but wait, but where does this piece fit? But where does this piece fit? And but now people are talking about integrating with Jenkins, and they throw up their hands and say, I have no idea what's going on. I'll just go back to saving files and folders. So we're going to try and demystify that a little bit in terms of what GitHub does. And I've noticed I've done Git-hub. So there's a Git component and there's a GitHub component. Recent news is that GitHub was bought by Microsoft. they're putting a bunch of capital behind it. So and GitHub is evolving with things like Gist, and the people are publishing books on GitHub. So GitHub is growing, changing, and evolving. So this is definitely going to be a platform in the future. The other thing is that there are an awful lot of copycats, which are perfectly good platforms in their own right, like Bitbucket and some of these other ones. And we're not going to touch on those, but they are very similar in model to GitHub. So this is now also GitHub not only being kind of a dominant tool that people are using, but it also now is representing the dominant model in our collaborate, share, and build paradigm. And GitHub is a critical part of all of the different kinds of methodologies out there, from DevOps to Agile. And so let's get into it. Okay, so what we want to do is talk a little bit about source control management, then talk about the GitHub model. We're going to look at working with Git locally, and then we're going to look at the collaborative model using GitHub. And this is basically the idea of version control is you got to keep track of your stuff. And if anybody's tried to work with version control, that not do stuff without version control, you spend a lot of time looking for things in the right version. So we're not going to make the argument for version control today. That argument has already been made very well by almost anybody who's experienced what happens when we don't have version control. So what version control does is it manages, in its conceptual idea, is that we version objects. The standard model is I save a version under version control, I make changes, and I get version 2. And usually what my version control system does is it remembers the changes it got from version 1 to version 2. And then when I make version 3, it remembers the changes from version 3 to version 2. So I can always go backwards and recover any of these versions. Okay, so the idea is that this is a fairly standard model. We're not going to talk about version control per se. We've only got about half an hour, 45 minutes. So we'll just say that version control, good. Version control, should you use it? Yes. And you can use it for anything that is constantly being collaborated with or being used. So this version control is the notion of like a local version control. So you might set up a little local repository on your machine, and there's your local version control system. But then what happens is that we move to this next model of what we call centralized version control, where the repository is no longer on your machine. And this is the classic clear case model, and you'll find this in a lot of large corporate environments, where you've got the corporate repository or the institutional repository, and people check stuff out of that repository, work on it, and then they update it back to that repository, and they commit. And so people are always checking out the latest version. And this allows for collaboration, because everybody's working on the same document, and two people can check it out at the same time, and there's ways to reconcile the changes when they commit it back into the repository. And that was kind of those two were the two models that we tended to see, is where we had both we had either a local version or we had the centralized version. And of course, this produces a bit of a problem, as you know, I've been in a number of organizations which use something like ClearCase, which is this model, and the network goes down and suddenly nobody can do any work because nobody can access the repository. Or if somebody wants to work on a plane as they're flying from one office to another, they can't connect to the repository. And so there's a number of definite limitations to this model. The model that we're looking at in GitHub and Git is what is now considered to be the standard model, this distributed version model. So each person is working on their own local copy of the repository. They're committing updates to the repository. They're doing version control on the repository. And everybody has their own copy of the repository, and then they synchronize with a master repository, and which we call pushing and pulling. And we'll look at that mechanism as we get a little bit later on in the session today. Okay, so now we come to this idea of the Git workflow, and there's a local workflow, And this is where people often get confused because it's got this notion of adding and statuses and everything else. So what we're going to do is we're going to just work through a little bit of how Git works locally and some of the ideas behind local Git. And then we're going to see how we use that to create a collaborative environment with GitHub. Okay, so this whole thing looks really mysterious if you haven't seen Git too before. So we're going to take a little look into it. Now, before we do that, we are going to introduce one concept that's called branching. And because we're going to see this term master branch. Now, one of the things we have to do is we're going to organize things for people to collaborate with. So we keep a master copy of everything called the master branch, and we call this the single source of truth. This is always our most recent, current, and correct version of whatever we're working on. People do not change things in the master branch. What they do is if somebody wants to work on development, they check out, for example, here's version 1, version 2, and version 3 versions of our product in our branch. And so if we want to start working on something, we wind up going and checking out a branch. What a branch is a copy of whatever we checked out. And then we work on the copies, and if people want to work on the same copy at different times, at different parts of the copy, they check out their copy of the copy, and those we call these feature branches. So what happens is our developers have started a development project, and they create this development branch, which is a copy of the master from the point they wanted to do their development. And as each developer works on something, they check out their copy of what they're working on, and then they merge it back into the branch. So they're not, so these guys here are working in parallel to each other. They're not stepping on each other's code. And then at some point, they're going to merge everything back into this development branch. And this development branch is going to, when they do the merges, they're going to reconcile any differences in the code. They're going to make sure that everybody's code is correct. And then they're going to come down here. And at some point, they're going to push this back up into the master branch or repository, and then they're going to carry on with the next project. Or another way to look at it, if there's my master branch, I create a copy called my development branch, and my different developers are creating their branches. They're merging back into my development branch when they're finished their work, and we finally get a nice integrated copy here. This is release 2, and so we go and do our various kinds of smoke testing and unit testing and functional testing. Yes, our release 2 works, and then what we do is then we push it back into the master branch, and then we've updated our one single source of truth. So branching is a way of creating copies to work on, and then merging is adding those modified copies back into the branch that we took them from originally. Fundamental rule is that no development work takes place on the master. All development work takes place on branches. And by the way, it's not just code, but we can talk about writing a document as well. But the rule is that every time you branch, there must either be an end to that branch in which you say, okay, that's it, we're not going to work on this anymore, we're shutting it down, or that branch has to merge back into the master repository. Okay, so let's now go back and look at that workflow. We're going to do a live demonstration, but not that kind of demonstration. We're going to actually take a look at how this works. And in order to do that, I've set up here on my little machine and I hope everybody can see that. It's shared correctly. If not, let me know right away. And I'm going to just create a lovely little Git repository in my computer. And so I'm going to do this very simply. I'm going to create a directory that's going to serve as my repository. And let's see if I can actually type this correctly. And make directory, and we're going to call this demo repo. And I'm going to go into my demo repo. And this is going to become my repository. So Git is installed on my machine here. And so I can say, okay, what's the status of my repository? And Git's going to tell me, you actually don't have a repository here. I say, okay, well, let's create a repository very simply. I'll just say git init, and what Git is doing is it's setting up a repository. Well, what does this repository actually look like? Well, let's take a look so we can see what Git actually did there. Okay, so there's my, where it is, demo repo, there it is. And we'll see that there's this full a directory called .git. It's a hidden directory. But if I open it up, it's got all kinds of stuff in here. And this is where Git is managing. This is the actual Git repository itself. And we're not going to go into what all of these things are, not in this high-level overview. All you need to know is that Git is now has created a repository structure that I can use. Now I can do my Git status again. And Git, it says, well, you haven't actually done anything yet, but you're on your branch master. So I've actually remembered that's that branch master. So what I'm going to do is I'm going to create a little file here called f.txt, just for file. I want to create it, yes, and I'm going to say this is my file. I'm going to save that file, and I'm going to. So if I actually look in my directory, there's my file. I've created it, and I ask Git, so what's going on with my repository here? And Git gives me this thing, say, well, you know what? You got a file, but I don't know if you want to put it in the repository or not. And so what Git has is a staging area. A staging area is kind of like a little place where I can tee up all the files I'm going to put into my repository. So let's take a look at how I would do that. I would do, in this case, I would do git add. And what the add command does is it says, okay, these are the files. This is what I want to put into my repository. So I'm going to do git add, and I'm going to do that. And now if I ask Git what's going on, Git's going to say, well, you've got one file, but you're telling me that's going to go to the repository, but you haven't actually committed into the repository. Now, the staging area allows me to fiddle around and before I do a commit and figure out exactly what it is I want to do. So in this particular case, what I want to do is I just want to commit the file to my repository. So I'm going to say, okay, and it says, okay, take all the stuff I put in the staging area and put it in my repository. I have to give a message because the repository needs some kind of comment, forces me to comment as to what is that I'm actually doing. In initial commit, and I put it in there, and it says, there, you've got a file changed, and now I can do git status. And there's my branch. Okay, so that is the idea behind my repository. Now, we mentioned that if I do git status, in fact, if I do git lb, which is a little command that we've set up here. Oops, I think I put I aliased a command here. There it is. And so I just told Git to list what's going on, and it said you've done an initial commit. There's the start of your repository. It's a lot of information. Okay, so what I can do is I can create a copy. I can do checkout, and I can. Oh, I'm sorry. I got to put Git in there. Oops. I can do Git checkout, and in this case, I'm going to create a branch called working. I'll call it work. And what's happened is that it's now created a copy. And if I do git status, I'm now on my branch work. And I'm now working with a copy of F. So let's do notepad f.txt. And I'm going to say this is on working. So I'm going to edit this. There we go. We've edited that. And now what I'm going to do is if I do git hold on here, git L, I can actually see something interesting here is now I'm actually got this working branch. And so I'm going to add the file my repository, but it's going to be in this working branch. And I've got to keep remembering to type Git in there. I'm going to do this. Okay, so I'm just going to clear my screen for a bit here so it's easier to see. I can do Git status. And now it says you've got that file. Do you want to commit it? I'm going to say Git commit. And then I'm going to Git commit. My message is going to be, whoops, my hyphen key doesn't want to work there. Working, that's my working branch. And so I'll put that in there. Okay, so now I've got so I've got this working copy, but let's go back to my master branch now. So checkout is the command that I use to switch branches. So I'm going to go back to my master, oops, because I've got to do git checkout. And I'm on my master branch. So what I just did was I just edited a copy on the working branch, but I'm on the master branch. So what would happen in there? Well, there's my original file. It doesn't have this on working part here. So I've now got two copies of f.txt in two different branches, and I could have multiple branches. But what I can actually do is I can go and do a merge and merge these branches back together. So let's actually take a look at Git L and see what's going on in Git. So now it's basically telling me you've got a couple of different copies. You've got these two branches. You've got this master branch where you made your initial commit. You've got this working branch where you've made a commit, and I'm in. Let's figure out what branch I'm in. And I'm on branch master, so I'm going to do git merge working. I'm going to say, but I want that to merge those working copies work. And so now it's going to say, oh, okay, I'll take the copy and I'll add all of the changes that you made in the copy to the original. Okay, now I'm still in my master branch, but now when I type out the file, you can see that it's incorporated the merges. Okay, so this is basically the workflow that I'm working with in my local repository. Okay, so now, but what about the collaboration part? Well, there's a couple of things that I can do. Is I've decided now, for example, that I want to share this brilliant piece of work with other people and have them work on it as well. So how do I actually share this work? Well, what I can do is I can go and let's go here. Unfortunately, I don't want this one here. Let's log out here. This is, I'm going to log out of GitHub here. Sorry, I'm in the wrong one here. We'll go into here and I'm going to log out. This is my actual one here. Oh, here we go. Hold on. I think this is where I should be. Yes. And so this is, I set this guy up as a repository here. And I've created an Xnode demo as my repository. And what I'm going to do is just go to my home page here. The Xnosis is my actual repository, and I was just going to use that to demonstrate some forking. So here we go. So here's my GitHub repository. I don't have any repositories set up here. So I've created a GitHub account, and this is up on the web. It's GitHub. And what I'm going to do is I want to create a repository to use down here. So what I'm going to do is I'm going to go and I'm going to create a repository that I'm going to share with people. There's my new repository, and I'm going to call this a repository demo 1, and I'm going to create this repository, and it's going to be public so that anybody can share it. Now, once I've created this repository, what I want to be able to do is to go and put what I've got here locally up here and create a connection between the two so that GitHub knows that this repository is a copy of this demo. right, so how do I do that? Well, Git, for very, very lovely, tells me, so the first thing we're going to do is we're going to go and locally, we are going to go and create a linkage between this URL and whatever Git repository I run this in. So I'm going to come down here and I'm going to put this in here. And so now what I'm going to do is I'm going to create that linkage between the two, the one up there and the one down here. Okay, so now what I can do is I can now push. Now what a push does is it takes whatever I've got locally here and it puts it up into the repository. Now at this particular point, this command is a little bit more complicated than the ones that we actually will use normally. Let's come over here. And so it's git, and this is push, and this means we're going to update here, and we're going to push up to the origin, which is our GitHub repository, and we're going to push the master branch up there. I could put another branch in there, but this is a fairly standard one. So I'm going to push up to my origin. Okay, and it shouldn't take too long. There we go. So what it did was it went and it pushed all the objects out there, and it basically set up all of. So now it's created a linkage between that remote repository and this one. So can we actually see this? Well, let's go and take a look at this repository now, and there is my demo one repository, and it's got one branch, it's got two commit, and there's that F text file that I actually had just created down here. Okay, so there it is, it's up there. Now, so this is the idea. Now, as I'm working, I'm going to want people to continue to share my work. So what I'm going to do is I'm going to do notepad, let's do notepad g.txt. We'll create a new file. Notepad. We'll create the file and we'll just put some stuff in it because we don't really care what's in it. And then we're going to say, okay, I'm going to add some more stuff here. So we've got this lovely, same thing before. What do you want to do with this file you've just created? I'm going to do git add g.txt. So I'm going to add it to my staging area. And if I do a git status again, we'll see it's ready to be committed. So I will now do git commit -m and my comment added G. There we go. Okay, so now, whoops, git commit, there we go. So now I've added it there, but now my local repository is out of sync with my remote repository. So what I can do is I can just say git push. Okay, what git push is going to do is say, okay, take whatever you've got locally and push it up locally. So I can do git push, and it is going to say, there we go. So it's now going to update my remote repository. If I come over here and I refresh my display here. We should see here. There we go. There's demo. There we go. And now there's my G that's up here. There's my comment added G. Okay. So this is basically the idea of how we do this. Okay. So let's go back to look at our presentation for a moment. So we've looked with Git locally. We've taken our local working copy. We've created the staging area where we added stuff, then we put it into a local repo, and then we pushed this up into my GitHub repo. All right, so now we've got a lot of the workflow kind of nicely sorted out, but there's still a little bit more to do. So we still got to look at this notion of pulling stuff. How do we get other people's? So it's really great. I've got this stuff up in my GitHub repository, but how do I get it back? And how do I do other kinds of things? So to do this, we're going to look at how we get other people to share with us. Okay, and we're going to look at a concept called forking and cloning. And these can sound kind of intimidating. And this is where I actually have to go through my other account here. So let's suppose now that I want to work on a particular project. Now, if I want to work on the actual project, I can't do any. If somebody's got a project here, for example, here's my a demo project here, and I've forked this from somebody else. So I can also have a demo project here. So I'm going to actually go to this website and type code demo. So here's somebody's repository. This is Tippy code. And I say, you know what, I want to start working on this. So Tippy code probably doesn't want me working on their project. This is their project. In fact, they probably set this up so that I can't push anything up here because I'm not an authorized contributor. So what I do instead is I create a fork. So I fork, it creates my own copy under my own GitHub account. And so it's forking it now. And so now when I look at my demo accounts, I can say, ooh, here is a demo repository for this. I basically now have created a fork. And so it says here, fork from Tippy code demo. Okay, so now I've got a copy, I forked it, and this is a very common way for people to share work. If you want to work on a project, you often will fork it, create your own copy, work on that, so that you don't disrupt the original project. So that's what forking does. But now I want somebody to actually work on this. I actually want to work on my copy of this project. So what I can do is I can do what's called a clone. And what a clone does is it creates a local copy. Okay, so notice I created a local repository here and I pushed it up to the web. What I want to do instead is, and I'm going to just put an X here so I don't overwrite anything that I already got there. And so what I'm going to do is I'm actually going to do git clone. And then I'm going to put this repository here. Now what this is going to do is it is going to go and do the reverse of what we just did. It is going to go and download what was on the GitHub into a local repository. So this is what my cloning is doing. Okay, so now if I take a look at what I've got here, and if we go here and go into Rod, and I want to do this so it's easy to find, X, there's demo. It's exactly a copy of what was up on GitHub. Okay, so now what I can do is I can do pushes and pulls into my repository because I've actually got that available. So I can do a push, and if somebody else adds some stuff here, let's, for example, suppose that we come into our copy of the repository, and I'm going to emulate a change here. So here's the README file. So what I'm going to do is I'm going to edit this README file, and I'm going to just take some stuff out of here. And then what I'm going to do is I'm going to go and I'm going to commit the changes here. So I've actually changed the README file up here. So what's happened is this copy up here, and this could emulate somebody actually pushing data up to here. But now how do I actually get the changes? Well, Git says there are changes up there and I want to get them to my local repository. So I can just do a pull. And what pull does, oops, sorry. This was a demo here. There we go. And I can do a git pull. And what that does is it goes and pulls up whatever changes are made. Okay, so what happens now is if I look at the actual README file in here, you will see that in fact, whoops, is the file that was changed up there. So I edited all that stuff out. Okay, this is the fundamental operation of how GitHub works. This is it. You've basically seen all of the operations that go on GitHub. So if we take a look back at our presentation here, we wind up with again being able to clone repositories down into a local repository, work with those local repositories, push them up to the repository, pull new changes to the repository down into our local repository. So very often in standard operating procedures, I've got a bunch of changes. I'll pull down the repository to update my local copy with new ones, and I'll push it back up. And we have this choreography of collaboration. We're all working on these version control systems, but now our work is all being nicely collaborated. Okay, that's the essence of Git and GitHub right there. There is one more thing we took the pushing and pulling, but then we come to the other side of GitHub, which is fairly important. We've shared, but it's collaborating. So what we want to do is here's the idea, is that we go and we create a branch and we do a pull and and then people discuss the changes and we merge it back. But we've got a distributed environment, so we've got to have people know what's going on. So GitHub allows us to do certain things with these repositories to enable collaboration. This is the other strength of GitHub. So if I come into my demo that I've created here, I can go into my settings and I can do a couple of things. I can set up notifications, which allow me to, oh, I'm sorry, that's webhooks. Webhooks allow me to send events to other tools like Jenkins that will say, hey, something has happened and we here, like somebody's committed some code. Now we can pull it out and run it through a code analyzer or some kind of integration tool. We can also look at notifications. So here we go. There's my password. Okay, so I can set up notifications, so I can email out notifications, and I can set up notifications for various kinds of actions. And let's take a look at webhooks again. I think we should be able to see it here. So what my webhooks is going to do is enable me to integrate on a number of different events that are going to take place, and I can do this and send them to webhooks to send them to Slack, other notifications. So if somebody creates a branch, if somebody deletes a branch, if somebody does a fork, if somebody does any kind of operation here, a pull request, a push has taken place. If any kinds of these things take place, I can set up notifications right away that allow this to be propagated. I can also set up the collaborators that allow me to allow who gets to work on this repository. So not any old person can, for example, make contributions to my repository. If I try to push to somebody's repository, if I clone their repository and then make changes and try to push it back, I'm probably not going to be allowed to, because they probably have said only the people I want who are collaborators can contribute to that. We can integrate with a variety of other different services. I'm sorry, that's been deprecated. And we can also look at what kinds of actions we're going to allow for this repository. So what we have in GitHub is not just a passive repository, but what we can do is create a system where people are notified all over who are on our notification list, or other systems are notified when anything significant happens. So let's look at our notifications again very quickly. And we can set up in the notifications, and we can say what kinds of notifications do you actually want to have, and we can set up emails, particularly to get out notifications. So these are very useful things to have. So the basic idea of GitHub is really elegant. Is that we have this system that allows us to work locally, share collaboratively. There's a very effective means for pushing and pulling and forking and cloning. We also have a very effective way we can work entirely remote and unconnected from the internet. We can go up and work in our cabin up in Alaska and only come into town once a month and connect to the internet. and still collaborate. We also have ways of integrating with other tools so that it becomes part of a continuous integration, continuous build environment. And I would just take a look at that as well. Okay, so the idea is that again, the purpose of this brief overview was to demystify Git and GitHub and really present the elegance of its design and the reasons, or the number of the reasons why it has become the most popular way of doing collaborative work. So I would encourage all of you, if you have found GitHub and Git to be particularly mysterious up to this point, to consider it and how it may fit into the kinds of needs that you have in getting collaborative work, not just writing code, but this can be used for any kind of collaborative work. I use it, for example, for writing when I'm writing contributing to a common document that's being written by a number of authors. We can use GitHub as a collaborative tool to do that. So there's no limit to what you can do with GitHub as long as it involves collaboration and version control. It's an incredibly elegant tool. And at this point, having made my sales pitch for Git and GitHub and my professed admiration for it, I'll open the floor to questions. Anybody have any questions? Question, has Microsoft treated GitHub good to this point? Yeah, a lot of people were really concerned that Microsoft would kind of close it down. But one of the first things Microsoft did was they got rid of a lot of the fees that people were paying. They actually made GitHub more accessible. And Microsoft does seem to be taking an approach now of trying to be embracing the whole open source community and recognizing that's the future and becoming highly integrated into that. So for example, their latest version of PowerShell runs on Linux. So I think what we are seeing, given all the signs at Microsoft, is that this in fact is a good thing because Microsoft's got deep pockets. So it's giving some financial long-term stability to GitHub, but their policies toward GitHub so far have been are very similar. These slides are going to be shared, but this also is more of a demo, so I'd encourage you more to get the video so you can walk through the demo again. Is there going to be something from the webinar for Jenkins? Paul, we can put it in the bug in Paul's ear and see what happens. So we can certainly do that. Can Microsoft do any damage to Git? No, it can't. Git is already open source. Plus, if Microsoft tried to do something like make Git closed source proprietary, there would be a literal revolution. You have so many different versions of Git out there supported by the developer community that would be a pointless thing for Microsoft to do. I was skeptical when I first heard Microsoft was buying GitHub. I thought, oh dear, where's this going to go? Because I'd already been through that experience with Oracle and Java and MySQL. But Microsoft, again, I think has really rethought their future going forward, and they're really trying to win over the GitHub community because they also know that represents an incredible base of some of the best and smartest people in the industry right now. So they don't want to alienate them. So I'm optimistic going forward that Microsoft will do right by GitHub. I haven't seen anything to make me suggest that they won't. Okay, it's good questions. Yeah. Any others? Let me see if I've missed any here. All right, so that, wait a few more minutes. Okay, if we fork the project, we can't get any updates after the fork project, how to overcome this? Okay, one of the problems is that if you forked a project, you've really created a separate project. And so you have to look at at getting updates from the original project as a separate issue from getting updates from the fork project. So if I forked that Tippy code project, I am not going to get any updates from Tippy code because my fork is basically an entirely new clean copy of that project. So if you want to get updates on the original project, you would have to set that as well. So you really have two separate projects you have to do updates for. That doesn't go on. Refork it, yeah, a good idea. So go back and check on the settings. Now, when you have a new project, if you had set up notifications for the original project and forked it over, it's not necessarily that those notification settings are going to be copied over. So go into your forked project and manually set your notifications again to ensure if that's what you want. All right. So you've got to remember that forked project is a brand new project. It's not going to be connected to the original project anymore. All right, other questions? I'm using it right now in this demo on a VirtualBox machine running Windows 10. So you've seen it run, it's fine here. Yeah, Git runs on all the major platforms, Unix type platforms, Windows platforms. I don't know about legacy Windows platforms, and I use it on Unix all the time. DevOps is actually more of a philosophy rather than an approach. And I know that Microsoft, I don't think Microsoft owns DevOps. DevOps is an approach to building software involving kind of the rethinking the roles involved in software, developing a philosophy of continuous integration and development, and then automating that process with tools like GitHub and Jenkins and other similar tools, like Ansible. So DevOps is pretty much like Agile. Nobody can actually own it. Even if they try, prior art would certainly prevent them. GitHub is heavily used in DevOps. It's also used heavily in Agile. So the Git DevOps also uses tools like Bitbucket and the Atlassian tools. There are other alternatives out there, but yeah, all the DevOps Agile tend to use something like Git or GitHub is kind of the tool of choice to do this kind of management. Are the new versions of Git critical to have? I don't think they're really that critical. I don't think there's been any major releases, but it's probably a good idea to update if a new major release Git comes up. Normally it has enhancements and fixes, so it's a good idea. But I know that also the developers and supporters of Git try to make everything backwards compatible, so you shouldn't break old GitHub repositories, but there should also be a migration path there. Anything else? Would you hire someone who hasn't heard of GitHub? Depends on what I'm hiring them for. Yeah, I think that all that represents is kind of their background. So I work with often very, very good developers who've been in a corporate or government environment for decades, top of their game, but in a lot of places they've just never used these tools. They've used different tools. So if I was going to hire somebody who looked really good but didn't know GitHub, I teach them. Because it's not that hard to learn. They may have come up from an environment that's been ClearCase their entire career. So I would hesitate on hiring somebody who didn't understand good source control management, but I'd hire somebody who hadn't heard of Git or GitHub if it's just something they hadn't been exposed to. And there are a lot of people like that out there, particularly in government agencies where they've got massive server type, ClearCase type installations. That's all they've actually done. But if somebody's doing open source work, it would be pretty unlikely if they hadn't heard of Git or GitHub. Yeah, ClearCase, ClearCase is the granddaddy. It's still in extensive use throughout the government, which is really remarkable, and a number of large organizations. So they're trying to migrate away from it. I actually wind up doing a lot of ClearCase consulting, interestingly enough. Okay, any other questions? I think maybe not Git per se, but I think what happens is the model that Git has produced is going to continue to be the dominate sort of the industry as a standard for some time to come. It's always is a pretty long time, but I would say for the foreseeable future, Git and GitHub are probably, or Git and GitHub-like tools are probably going to be the way to go. But that's probably what we're going to see. The growth and adoption has been so spectacular across industry segments that I don't see it. The other thing too is to remember too is that organizations don't have to use public GitHubs. They can license the code, and they can create their own GitHub repositories or own versions of GitHub in their corporate networks that can only be accessed internally. So there's so many things that you can do with it that'll probably be around for some time. GitLab, I can't really say too much about the difference because I don't really know too much about some of the competitors, except I've used them now and then. I would say that most of them, and GitLab in particular, they tend to all share similar kinds of models and functionality. There's some things you can do in GitLab you can't do in GitHub, and some things you can do in GitHub you can't do in GitLab, and the same with some of the other things. So very often choosing the repository tool may often hinge on whether or not there's certain features specific to that tool that you really want to have in your automation environment. Why the name Git? There's actually a story behind that, and I can't remember what it is, but Linus Thorvald, when he's describing Git, he tells a story. The standard answer now is just because you can go and get stuff. So that's, but there is actually apparently some other inside story to that, and I just can't recall from offhand. But if you catch any of Linus Thorvald's lectures on Git and GitHub, he'll tell that story. So. And sometimes he denies that there is any significance to the name at all. So I don't know. Interesting bit of folklore. I think a lot of coders, because Git seems intimidating because of this staged local stages and the way branches work, trying to get their mind into managing code can intimidate some programmers who've never done this before. So yeah, I would say not all. I would say nowadays a lot of the younger programmers that are coming out have grown up sort of professionally with Git, so it's part of what they do. Whereas I think some programmers who haven't had exposed to the environment find it a bit intimidating to start with, because getting straight the architecture we just went through and how the programmers how the multi-stage model locally works. Unless you walk through it carefully. In fact, when I do a lot of courses, I used to do courses involving this, a lot of coders would say afterwards, oh, is that all there is to Git? I thought it was a lot more complicated than that. I didn't want to use it because I thought it was really, really complicated. So a lot of it is kind of just not really understanding the simplicity of it. The hardest part of Git is basically, I would say probably, not Git itself, but setting up a good collaborative model with branches and keeping track of all your branches and all of the different things that you can do with Git. And I would say the hardest part of Git is trying to maintain discipline so that you're using the features that are appropriate, and not just kind of blowing up your code with thousands of branches and all kinds of strange things going on. You can go back to Mitch Hedberg's original comment, which is that computers enable you to make mistakes faster than any other invention in history, with the exception of tequila and handguns. And so you can put your stuff into Git and you can just kind of trash it after a little while just by not using Git in a disciplined and sensible manner. But then you can do that with any tool. So I would say the hardest part of Git is developing your actual management. Any recommendation on benchmark for number of branches or clean branch structure? I'm going to suggest that we go back to Martin Fowler's comment, a fool with a tool is still a fool. Git automates your collaborative process. If you have a crappy collaborative process, it's going to show up in Git. You're going to get way too many branches. You're going to get conflicting merges. The single most important thing to do is get your collaborative process, get your workflows sorted out first, then implement them into Git. And if you get really complicated branches and really weird things like branches with nothing on them, that is a symptom that you have to go back and look at how your people are using Git. So Git lets you do anything. Okay, yeah. So very often you have to agree on how you're going to use Git as a team, so you don't trash your work with really dumb things that you're doing in GitHub. So Git is just a local part that works on your machine that I was doing at the command line, and GitHub is that web repository that's up somewhere on the web. That's really how we distinguish between the two. They're both repositories. When we talk about Git is the functional ones locally on our machine, whereas GitHub is up at the web-based stuff.
We are Starweaver, education you can bank on. For more information, contact us.